Hey folks, we're going to do an exploratory activity to figure out the area formula for a regular polygon. So first thing I'd like you to do is set up your notes. And I also want to show you this really cool picture. This is the James Webb Space Telescope. And each one of these hexagons is a mirror that reflects an image back onto a focal point. Crazy the amount of detail in these regular hexagons and the amount of information I'm sure they know about the material that they used and the area and all that kind of stuff. So what we're trying to do is figure out the area of a regular polygon. So here I drew a hexagon and let's set up our notes. You might want to put the video on pause and make your drawings and all that kind of stuff. But we're ultimately trying to generate a formula that will tell us the area of this regular polygon. And there's some information that we need to know, some vocabulary, that there's a center to this regular polygon. Now, how in the heck could there be a center? Like, why would they call it a center? Well, if I switch over to my circle tool, I should be able to make that center the center of a circle, and the circle would go through all of the vertices. So you can see I didn't put it in exactly the right spot because the top, it's not touching the vertices. So I'm going to adjust my circle a little bit so that it goes around the hexagon and it goes through all the vertices. So that's why they call it a center. And then I hope this makes sense. If I drew a segment from that center down to a vertex, this would be called a radius. So add that to your notes. That's a radius. This is a radius. I missed. This is a radius. How many would we have? Well, in this hexagon, we'd have 6 radiuses, right? The plural for that is radii. So I'm going to just draw them all in there. All right. So that's, 6 radiuses. Then we'd have a central angle, right? So let's put that in here. There's our central angle. Central angle. We have an interior angle down here. See this interior angle right there? Now, the interior angle is getting bisected by a radius. I hope that all makes sense. Let's put out here interior angle. We're going to need to find that information on a lot of our homework problems dealing with these regular polygons. You would be able to find an exterior angle, right? If you extended one of the sides and we drew over here, let's put 3 little arcs on that. That'd be an exterior angle. Okay, so we have an exterior angle, we have an interior angle. Now I regret putting interior angle over here because, that's like right in there. Okay, hopefully that makes sense. Now, this is going to be brand new. I bet most of us have never heard this word before in their life. So I'm going to go from the center to the midpoint of the segment. It did not choose green. Come on, choose green. I'm going to change my color here. And so I'm going to go from the center to the midpoint perpendicularly. I don't know why I'm having a hard time with my pen tool. This thing right here is called the apothem. So let's put that on there. A-P-O-T-H-E-M. The apothem goes from the center to a midpoint of one of the sides perpendicularly. Okay. Let's see. What other information do we need right now in order to start our activity? I think those are the key parts. I guess maybe they do, obviously this is a side right here, a side length. Okay, so this is the side of the regular polygon, and we often use the letter S for the side length. Okay. Oh, perimeter. We're going to need to know something about perimeter. The perimeter is the side length times the number of sides we have, and they quite often use n for the number of sides. So let's put down side length times n, however many sides you have, right? That would be the perimeter of our polygon. And this is a 6-sided hexagon, right? They're not all going to be hexagons. So if you're like, why isn't he putting a 6 in for the n? That's because they're not all hexagons in our homework. So here's what's going to happen next. So we've just set up our notes, right? Let's go back over to our Google Classroom. We just set up our notes. I need you to open up the Desmos file that's attached right down here. So when you open that up, what I'd like you to try to do is tile it on the screen. So you're going to drag that off of the Google Classroom so that it can be a separate little window, right? Now I've opened up my Desmos file. Really important. You open up that Desmos file. It's all set up for you the way I like it set up. Then this is the tricky part. You're going to open the course slideshow in McGraw-Hill. So let me show you how to do that. Here's McGraw-Hill, and here's the course right here. Course. You got to click on that button right there, and you're going to go to the correct module. See, I'm in module 6 measurement right now. That's lesson 2, section 2. So let's say you're not in the right one. So let's say you're back here when it opens up, like in similarity. You want to click on this little symbol, and then you can close down module 3. You can go down here to module 6, open module 6 up, and go to lesson 2. So we definitely need to be here. And then I've already set up the presentation so it takes you right to the most important slide that we're going to use in the presentation. So if you click on that guy, it's going to open up the correct slide, and we want to have exercise 1 open. You can skip anything else. You want to get exercise 1 open, and this is what you want on your screen. If it's too big, like you're too zoomed in, you can't see everything you need to see, zoom out a little bit, right? You can do that by clicking, I think, maybe these little bubbles over here or some way you can zoom out so you can see that. Then we want to have Desmos on the same screen. So my Desmos file is right here. So we'd like that right there, this here, and we're going to take these pieces of information. First, we're going to start out with a 3-sided polygon. So on the worksheet, the first row is a 3-sided polygon. So I'm going to adjust that. And you'll notice that I have the measurements in my Desmos file. So 0.25 for the apothem. There's the apothem. Remember, it goes from the center to the side perpendicularly. They've measured that for you. Then we've got a side length of 0.866 along here. So that's going right there. Now, if I want the whole polygon's area, I'm taking 3 times the area of that one triangle. This triangle right here, we're taking 3 times the area of that one triangle. Wouldn't the area of that triangle be the apothem times the side length? Because the formula for a triangle is 1/2. Well, not just the apothem times side length. We got to take 1/2. 1/2 the apothem times the side length, because it's 1/2 the height times the base, right? So I'm taking 1/2 the height times the base. And so that's the area of one of my triangles. Now, if I take 3 of them, because there's a triangle here, and there's a triangle here, and there's a triangle there, I'd have the area of the whole polygon. So that is the regular triangle. The next one in your worksheet is a 4-sided figure. So you drag that guy over to 4, and you need to adjust these numbers right here. So now the apothem's not 0.25, it's 0.35. So let's just change it to 0.35. And I'm not worried so much about where you round to and all that stuff. And then the side length is 0.707, 0.707. And then I need to take, 3 times, no, not 3 times the area. I need to take 4 times the area, because there's now 4 triangles. There's a triangle here, triangle there, and so on. So now we got the 0.49. Now you're going to record this information on your worksheet, okay, and this information too. All right, good luck, everybody. Our goal, let me just reemphasize the goal, is to figure out what is a formula for area. Now, this is going to happen on step 6 of the worksheet. It won't happen until step 6. They're trying to walk you through to get to this formula. When you leave today, I hope you can use that formula on a problem or 2 in homework. So thanks for watching my video and setting up your notes and working with a partner.